Quadratics. So it's going to be all about quadratic equations. Okay. So
Yes.
there's a standard form of any quadratic equation. So first of all, just have a look into the standard form. So a standard form of any quadratic equation, this is how it looks like. So ax squared plus bx plus c equals to 0. Okay, so when it means to solve the quadratic equation, that means that you need to know the value of x involved in this equation. And the solution of any quadratic equation is known as basically the roots of quadratic. Basically, whenever you come across a term, roots of any quadratic, so that means, for example, examiner asks you to find out the roots of quadratic, it means that examiner is asking you to find out the solution. In simple, even more simply, he's asking you to solve the quadratic equation. For example, you have a quadratic equation, and at the end, you get two answers as x equals to 2 and x equals to minus 3. So basically, both of these, they are the roots of a quadratic equation. Okay?
Yes, sir.
All right. Now, there are different ways you can solve a quadratic equation. So ax squared plus bx plus c equals to 0. I'm talking about the equation which is in its full form. Okay. Now, you can solve this type of equation by two different methods. One is by factorization, and the other one is by using quadratic formula. Okay.
Yes, sir.
So one and there, so these are the two methods. One is by factorization. We studied factorization yesterday. So a three-term quadratic can be factorized by using a middle term breaking method. So we clearly mean, when I say factorization here, so we clearly mean that we are going to break the middle term. Okay.
Yes, sir.
And the quadratic formula, definitely, I'm sure you know it, but just for the safe side, I'm going to write it down here. So minus b plus minus b squared minus 4ac whole divided by 2a. This b, a, and c, these are basically the letters which you can see in the standard form. So a is the coefficient of x squared, b is the coefficient of x, and c is the constant at the end. So these are the two main methods by which you can solve any quadratic equation. Uh, a full form quadratic equation. A full form quadratic equation means it has got all of the three terms. All right.
Yes, sir.
Okay. Yesterday we also studied that any three-term expression can be converted into a quadratic if the power of the one is half of the other one. So the same rule applies over here as well. So if one is so this rule also applies for, so I'm going to write it down over here. So if one of them is 2m, the other power is just m. So plus c equals to 0. So the same rules will be applied for both of these. But before applying the factorization or quadratic formula, you will be converting this into proper quadratic and then applying either of these two techniques in order to solve it. Okay, now this is when you have complete full form of quadratic. Now, this equation is called a quadratic just because of this first squared term. If either of these two or both of these are missing, it is still going to be quadratic. So let's just have a look into other forms of quadratic. One of the form is ax squared plus bx equals to 0. Now in this particular case, the last constant term is missing. Now, although you can solve this one by using quadratic formula, but that won't be wise to do that because this is designed uh, to do the full form. Okay, So because it has an involvement of zero and everything, so you don't have to use this big machinery to sort out this tiny stuff. So you're simply going to factorize it, and then you are going to solve it. So you'll be solving this by factorization method. And when I say factorization over here, I don't mean middle term. Middle term is only for three-term quadratic. Over here, you can clearly see there are two terms. So either you're going to um, take common, or you will see if you can write them down as a difference of square. Then you apply the third identity, or you do handle it accordingly. Okay.
Yes, sir.
All right. Now moving on to the third possibility. That's ax squared plus c equals to 0. That's not there. It won't be plus c. It will be basically minus c all the time. I'll tell you the reason in a minute. We'll be doing a type of this question in a while. All right. Whenever you have this type of equations, this means this is the equation in which you don't have the middle term. You have the first square term and then just the constant with a negative sign. So whenever you have this, you have two different methods or two different approaches to do that. So the best one is to make x the subject of the equation, because there's just one variable which is x squared. So any one variable equation can be solved by making that variable a subject. I've got two variables with different powers here. I've got two variables with different powers here. I won't be able to make x the subject. Over here, it's very easy for me to make x the subject of the equation like this. So I'm going to do ax squared equals c, x squared equals c over a, and then x would be equals to plus minus root of c over a. Okay, so this way I can solve it for the value of x. Or other method is definitely by factorization. If you want to solve it by factorization, if it is factorizable. Okay.
Yes, sir.
All right. Another possibility is that you have factors and those factors are equal to some kind of a number. For example, p, which is not 0. P is not equals to 0. Okay, so p is going to p can be any number but not 0. So these type, now this is clearly a quadratic, so x times x is going to give you x squared. So for these type of questions, you will expand the left hand side first, and then you will dissolve the p on the right to into the constant on the left. For example, after expanding this, you get something like x squared plus 2x plus 4, for example, okay? And this number
Yes.
over here is 3. The p on the right is 3. So you've done the first step that you have expanded the left-hand side. Now in the next step, you need to dissolve this constant into the constant on the left-hand side. So you'll be bringing this onto the left and doing 4 minus 3, which is going to give you 1. So you'll be just left with one constant that is just 1. And you will be left with 0 on the right-hand side. So this is going to give you a standard form. So you will end up with standard form. Then you apply factorization or quadratic formula, whatever is suitable. Okay.
Yes.
All right. Fifth one, x plus m, x plus n, but this time you have exactly 0 on the right hand side. This thing you will be getting a lot. when you do the middle term breaking method for solving purpose, when you'll be applying a middle term breaking method in factorization on the full form and over here as well. Now, over here you apply zero product property and equate each factor with 0 and then solve it accordingly. That's going to result in the linear one, result in two linear equations. So x plus n equals 0, x plus n equals 0. From here you can get two different values. Okay?
Yes, sir.
Alright. And then for example, you apply a completing square method on any quadratic equation or any quadratic. Yes, you apply a completing square method on either of these two. So yesterday we studied two possible outcomes. So you get, for example, you get one of the possible outcome, and that turns out as x plus p whole squared minus q equals 0. Okay, so this is what you are going to obtain after applying a completing square. So after applying completing square, this is what you're going to get. Okay.
Yes, sir.
All right. Now, once you have this, now if you look carefully, the shape is different, but the rules somehow they keep repeating themselves. And if you look carefully at this equation, this is the equation with one variable, just like this one, where you have just one variable, no matter what the power is. Over here, you have two variables, like with two different powers, so you won't be able to make x the subject of the equation. Over here, you have just one variable, no matter what the power is. So all you gotta do is make x the subject of the equation.
Okay, sir.
Make x the subject of the equation. Okay? All right, so these are all possibilities of quadratics, solvable quadratics. So one is the full form, and then I have even mentioned. So this one is basically, you can call it as coded quadratics. Means they don't look like quadratic, but they are. Technically, you can convert them into quadratics. So they are known as coded quadratics. Coded quadratics, a quadratic with missing constant term, a quadratic with the missing middle term, a factorized quadratic on the left, but there is a constant number on the right. So this is a bit lengthy process. Like you will expand them first and then dissolve them, and then you will have reached to this point, and then you will start solving by either of the methods. This is the very easiest one. You already have factors in that they are equals to 0. So all you get to do is just apply the zero product property and get your desired answer. Over here, this looks very tricky, but this is very simple because if you give a good look at it, there's just one variable. So all you have to do is make x the subject of the equation by applying simple algebraic manipulation. Clear?
Yes.
All right, now about the roots of the quadratic. Roots of quadratic as in what about the solution of the quadratic. Let's discuss their nature. Now, there are basically three main different types. So One of them is imaginary, or you can also call it as complex roots. And then you've got, actually, wait, sorry. So there are two major division, there are two of them. One is imaginary roots or complex roots, and the other one is real roots. Then real roots have two further, and they are basically called repeated and then distinct. Okay, a repeated root and distinct roots. Now, what do we actually mean by this? Imaginary roots, that you won't be able to solve the given quadratic equation by the methods which are mentioned up here. These methods which are mentioned up here, you won't be able to solve all of these methods. So you won't be technically, you won't be able to solve the equation. For example, let me just give you an example. X squared minus plus x plus 10 equals to 0. Now, if you want to solve this, first of all, you should be able to notice that no matter what you do, you won't be able to factorize it. And then you may want to switch to the quadratic formula method. So I'm going to just skip to the calculator for quick calculation. And then if I put the values into it, so A is 1, B is 1, C is 10. So if I hit equal, you should be able to see the letter I at the end of the calculation, the first answer. Do you see that?
Yes.
And if I hit equal again, so x2 also has a letter I at the end of its calculation. So it means you can use calculator to solve it, but by normal methods, you won't be able to solve it. So these are basically known as imaginary or complex roots. I'm going to talk about this in detail in a minute. Now, these are the types of roots which you have been dealing with up till now. I'm just giving them a name, so they're not new for you. So you've already been dealing with these. Repeated ones are there is basically two same answers. Remember, in a quadratic equation, you will always get two answers. Okay, always get two
Yes.
answers. Repeated roots are those basically where you have two same answers. So, for example, you get x equals 5 and another x equals 5. And this is when you're going to get, for example, you have, if I give you an example from the factorization point of view, you will have an equation that when you factorize it, you will get something like a special factor, x minus 5 whole squared equals to 0. So that if you apply zero product property, so you will write x minus 5 equals to 0 twice, that is going to give you x equals to 5 and x equals to 5. Okay, so that's
Yes.
basically repeated roots. And then distinct roots are definitely the ones which are different answers. Okay, you will have two different answers for your calculations. Got it?
Yes, sir.
All right. Now, how do I know before solving the question that what type of equation am I dealing with? So that you can calculate by, there's a thing called discriminant. Okay, now in a quadratic formula, let me just write down a quadratic formula here for you. So x equals minus b plus minus root of b squared minus 4ac, and then whole divided by 2a. This thing, which is inside the root, under the root, so basically b squared minus 4ac, this is called discriminant. Okay, so
Yes, sir.
if the discriminant is less than 0, means it's a negative number, then you will have complex roots. Then you have complex roots. If the discriminant is equals to 0, then you will have real and repeated roots. Got it? So yesterday I told you, if you remember, that how would you know before factorizing that you will get a special factor, like just for example, if I write it down here, x squared plus 10x plus 25. Now, how would I know before factorizing that if I'm going to get special factors or not? So this is how you would know. If you apply this, that if b squared minus 4ac equals to 0, means you will have special factors. Okay? That's why it is going to
Yes.
have repeated factors. So let's just apply. So b squared is going to be 10 squared minus 4 times a times c. So 100 minus 25 times 4 is also 100, which is equals to 0. So from here, I know if I apply completing square on it, I'm going to have x plus m whole square format. Okay?
Yes.
Because it has special factors. If it does not have special factors, then I will have x plus m whole squared minus n format. You will have something outside. Okay, next is if b squared minus 4ac is positive, I mean it's greater than 0, then you will have real and distinct roots. Got it?
Yes.
All right, so I'm going to write down a few equations and I would like you to solve them. Okay? Should I?
Yes, sir.
All right, so I'll be writing down the required methods to solve these. Although I have mentioned these up here as well, all of these, okay? So still, I'm writing it down in front of you. Can you share your screen instead? Hmm. Maniza? Hello?
Sir, can you hear me?
Yeah, I can. Can you?
Yes, it disconnected. This internet stopped working.
That's fine, not a problem. I was saying, if you can start sharing your screen instead. Have you written down all the questions?
No, sir, I was facing issues and then it just disconnected, so I couldn't view your screen.
Can you
I'll
not
just
see the screen now?
I can see it now. I couldn't see it before. Before it was blank.
All right, that's fine, that's fine.
I'll just quickly note this down.
Okay.
And then I solve these, right?
Yep.
Oh,
Or should I do it? Just you can. I'll give it to you for practice later on. Okay.
okay, sir.
So I'm gonna solve all of these quickly. Now the first one, the examiner. Let's just solve this by factorization. The first question is x squared plus 3x plus 2 equals 0. So x squared plus 3x plus 2 equals 0. And we'll be solving this by factorization. So we did that yesterday. So the product should be plus 2x squared, and the sum should be, as there's a positive sign here, so the sum should be positive 3x. Now clearly the two numbers are 2x and x. So the middle term would be broken down into plus 2x and plus x. I take common from the first two, x is common, x plus 2, plus 1 is common, and then x plus 2. X plus 2, x plus 1 equals 0. Now this thing over here, you've got the factors and you have 0 on the right hand side. So I'll be applying 0 product property. The 0 property states that the product is 0 if one of the factor or both of the factors are 0. So either x plus 2 equals to 0 or x plus 1 equals to 0. And this is going to give us x equals negative 2 and x equals negative 1. So these are the two roots for this one. The second is 3x squared minus 6x equals to 0. 3x squared minus 6x equals to 0. Now I have got two terms over here. Although I can solve this by using quadratic formula, but I won't be using that huge machine for this one, so I'll be just factorizing it. There are two terms, the minus sign, so I'm going to factorize it because I won't be able to rewrite them down as a difference of square. So I'll just take common. So 3x is common, and then x minus 2 equals to 0. If you look carefully, I've got three factors here. 1, 2, and 3. Okay? And all three factors there equals to 0. But again, I'm going to apply the 0 product property. Zero product property means the product equals to 0 means either one of the factors or all the factors are equals to 0. Now 3 can definitely not be equals to 0. So either x equals to 0 or x minus 2 equals to 0. From here, I'll say x equals to 2. So I've got two solutions for this one as well. Okay?
Yes.
All right, next is 3x squared minus 5 equals to 0. 3x squared minus 5 equals to 0. There's just one variable. I'm going to make this the subject of the equation. So 3x squared equals 5. X squared equals 5 by 3. I'll be taking root on both sides. And that's going to give me x equals plus minus root of 5 by 3. Okay, I can keep it like this, or if I want to give it in decimal, then I can convert it into decimal by using a calculator. Okay?
Yes. Sure.
Right.
I wanted to ask because usually in roots you can get plus or minus. So if you do not mention like the plus or minus, would like our marks be deducted for that?
Yes, definitely, because you need to know if you don't put plus or minus, it means it's got just one solution, and that is positive 5 root of 5 by 3. So you really need to put that. So remember, this is a rule of equation. Remember this as a rule of equation. Now, first rule, whenever you have quadratic, you need to have two roots. So even by chance, if you don't remember to put this, then if you have that in your head that you need to have two roots, you will be automatically start looking for the another root. From there, you will know that you forgot to put this. The second rule is in a quadrat, whenever there's this equation x squared equals anything, whenever you take a root on your own, that one of the thing is root of 4. That is just equals to 2. But if you're doing an equation, and you take root on your own. You took the root, not the examiner is not putting the root there. Then you will say that either it's +2 or -2. Okay?
Yes, sir.
All right. All right. The next question is 4x squared plus 17x. 4x squared plus 17x equals 6x minus 2x squared. 6x minus 2x squared. So first of all, I'll collect the like terms on one side of the equation. So 4x squared plus 2x squared plus 17x minus 6x equals 0. And then this is going to give us 6x squared plus 11x equals to 0. Now I'm left with, again, the same type of the equation where I've got two variables. I can't make x the subject, so I'll be definitely going for the factorization. I'll be taking common. From numbers, there is nothing common, so I'll just take x as common. So I'll be left with 6x plus 11 equals to 0. Then I'll be applying zero product property. And that's going to give us either x equals to 0 or 6x plus 11 equals to 0. And then x would be equals to negative 11 over 6. So I've got two answers again. Okay.
Yes, sir.
Okay, next question is 5x plus 3 equals root of 3x plus 7. 5x plus 3 equals root of 3x plus 7. What do you suggest? What are we going to do first?
First remove the root.
Shamash. So first of all, I'm going to take square on both sides and get rid of the roots. So on the left hand side, I'll be left with 5x plus 3 whole squared, and on the right, I have 3x plus 7. Now, I can't do anything about it because I don't have 0 on the right hand side. If it would have been 0, it would have been really easy. So I need to expand the left hand side so that I can dissolve these two unattended terms. So that's going to leave us with a squared plus 2ab plus b squared. So I've applied the first identity, and at the same time I'm bringing those two terms on the left side. That's going to give me 3 minus 3x minus 7 equals 0. So 25x squared plus 30x plus 9, 25x squared plus 30x minus 3x is 27x, 9 minus 7 is 2. So I'm going to use quadratic formula in order to solve this question. So A is 25, B is 27, and C is 2. And I'll be applying the formula here now. X equals minus B plus minus B squared minus 4AC, and then whole divided by 2A. X equals minus 27 plus minus, I'll do the discriminant part in one go. 27 squared minus 4 times 25 times 2. That's 529 over 50. I'm going to check if 529 is integer. Yes, it is. So x equals negative 27 plus minus 23 over 50. Now from here onwards, I'm going to split the two fractions. One with the positive sign and one with the negative sign. Okay?
Yes.
Now minus 27 plus 23 is minus 27 plus 23 over 50. That's negative 0.08. And then minus 27 minus 23 over 50. That's negative 1. So I have two roots as this. Okay? This was
Yes.
length. I told you whenever you have factors and then you expand them in order to get into the standard form, that becomes very lengthy. Okay?
Yes.
All right. Now the next is this one. You need to use formula. We've already done it. So I'm going to skip through these two questions. Let's actually I'll do this one because over here it's saying leaving your answer in the third form. So let's just see what does that mean. So 3x squared plus 10x minus 2 equals 0. Three x squared minus 10x plus 2 equals, was it minus 10x? Plus
No,
10x and
it's
then
plus.
minus 2. Plus 10x and then minus 2. All right. So I'm going to apply the formula again. So A is 3, B is 10, and C is negative 2. So x would be equals to minus 10 plus minus 10 squared minus 4a c whole divided by 2a. Minus 10 plus minus. Okay, so 10 squared. All right, this minus times this minus. The second term is going to be positive because of it, okay? So
Yes.
plus 4 times 3 times 2, that's 124 over 6. Negative 10. Okay, now I'm going to take root of 124, but I will leave it in the third form. Okay, so I've pressed, when you press this button, SD is going to take you back to the third form. One way is giving you decimal, and the other way is giving you simple third form. So that's 2 root of 3 plus minus 2, sorry, 2 root of 31 over 6. You can even further solve this by taking 2 common from the numerator because you will be able to cancel it out with 6 in the denominator. So I'm going to take 2 as common, and then you'll be left with, or you can do it minus 2 as common if you wish to. But actually, I'll just take 2 as common. So that's going to give you minus
Minus 5.
5 plus minus root of 31 over 6. And that will give you, upon simplifying, that will leave you with root of 31 plus minus, I'll write that down first, over 3. Okay? Or even if you want to keep minus 5 first, that doesn't matter. Actually, I'll leave that first. Minus 5 plus minus root of 31. So that's the third form. I'm going to want you to leave your answer in the third form. So this is what it means. That you have to
Okay.
leave it like this. Okay, now the last question was basically that you need to solve the same question by using quadratic formula. We've used quadratic formula twice in these questions. I'm going to skip through that one. Is this clear?
Yes, sir.
All right, great. Now moving on to the completing square form. We've done that yesterday, but let's just have a quick look on the questions there, how to do it one more time. Okay?
Okay, sir.
Completing square. Now, you have a question x squared plus 4x. Just a quick recap. you will always do this x. All right, so I'm going to write down a general ax squared plus bx plus c. Okay, so you will always do
Yes.
x plus if you have plus sign up here. And if you have minus sign up here with the middle term, then you're going to put minus down here. Okay? And you leave the blank, bracket close, and then square. Minus, and then blank, and then bracket. And then you will copy down whatever you have it here. Okay? With the sign. So it could be plus, it could be minus, it doesn't matter. So whatever there is, you just copy that down. So that's the basic standard formula. Like a shortcut method to do that. And before doing this, if the important thing is that the coefficient of x squared should be 1. If it's not 1, then you will take whatever the coefficient of x squared is, you will take that common from the entire expression. Okay?
Yes, sir.
I'll be doing two examples for you. So we have the linear term here has got positive sign. So I'll be doing it with the positive one. So x plus blank and then the square minus blank square, and there is nothing to copy down from here. There is no constant term, so I'll leave it as it is. Okay?
Yes.
All right, so what do we put in here? Half of the coefficient of linear terms. So b by 2 comes down in here. So b by, what's the half of 4? That's 2, so I'm going
2.
to put that. Yep, so x plus 2 whole square minus 4. That's the answer. Okay?
Yes.
All right, so now another question. It's 8x minus 2x squared. All right, first of all, I'm going to arrange this. Minus 2x squared plus 8x. Okay? I'll take
Yes.
minus 2 as common. So I have just x squared. Okay? Because the
Yes.
important point was that the coefficient of x squared has to be 1. If you want to apply this shortcut method, then the coefficient of x squared has to be 1. All right, now inside the bracket, I'll be applying this formula. So x, now you see it's got the minus sign over here. The linear term is minus. So x minus something whole square minus something whole square. And then again, there is no constant term to copy down, so I'll just leave it up to here. And then minus 2. Okay, so sorry, I forgot to put something. So that's going to be 2 inside. So x minus 2 whole squared minus 4. Now I'm going to open up the brackets. So minus 2, x minus 2 whole squared, and then minus minus is plus. That's it. Okay?
Uh, sir, with like the
Oh, oh,
minus
oh,
2
oh.
and plus 4.
Sorry. So that's going to be plus 8.
Okay.
Is that what you were
Go ahead,
saying?
sir. Yes, that is what I was
All
saying.
right. Okay,
Go ahead, sir.
now I'm going to give you one question for you to do it. Okay?
Okay.
So the question is, five x squared minus 15x plus 3. Don't worry if you can't. If do you know how if that you need to? Okay, what is the first thing which you're gonna do over here?
We have to like make sure that x is like 1. So we'll take 5 as
One
common.
from the entire expression, not from just the first two. Okay.
Yes.
So what will you do over here?
Um, we'll change it into like 1 over 3, I think. No,
No,
3
that
over 5.
yeah, 3/5. Shabash. All right, tell me. You just guide me. I'll go through it. I'll do it.
Okay.
You tell me
So
what to
we'll
do
take
next.
first we'll take 5 as common.
Mm-hmm.
So we'll have x squared minus 3 3x plus 3 over 5.
Great.
Then we'll put it in like the completing the square format. So it should be 5x minus something whole square plus
Minus. This is
minus
going to be minus all the time, okay?
okay, minus the same thing squared plus 3 over 5. And that will be 3 over 2 in both of the places. So
Okay.
then we'll simplify it. 3 um, it plus 3 over 5. So we have plus 57 over
You
20.
can. Are you giving me the final answer?
Yes, I just went to that.
Did you say negative 50? Did you say 57 over 20?
Yes, I wrote it wrong. It's minus 33 over 20. I did the square, but I put the negative inside the brackets. That's what I got.
No. That's outside. Okay. All right.
Yes,
So that's negative 33 over 20.
yes.
All right. Now what next?
And then we'll move the 5 back. We'll remove the bracket, and it'll be
Mm-hmm.
5x minus 3 over 2 whole square,
Mm-hmm.
and negative 33 over 4.
Shabash. Very good. Great. Okay. Now there's a question which came in exam. It's an exam question. It was of 3 marks. The question is write 2 plus 0.8x minus 0.04x squared in the form capital A minus capital B times x plus c whole squared. Find A, B, and C. All right, do it and send me. Okay.
Okay. Sir, I solved it, but I'm not sure how to get it in like the format that they gave. Sir, are you there?
Yeah.
Sir,
Sorry, I went to get a glass of water. Yep.
Sir, I got it in the like completing the square format, but I'm not sure how to like give the answer in the one that they asked.
What is your answer?
I got negative 0.04 into x plus 10 whole square plus 2.
Into x plus?
10 whole square
And then
plus 2.
plus 2.
Yes.
You got it right. So look, what is a? Look here. What in your answer? What looks like a? Look at the nature
Plus
of
2?
a over. Yeah.
Oh,
And what about b? Look at the nature and the
negative
position of the.
0.04,
Nice. And what about c?
10.
Shabash. Great. Okay, b is not going to be negative 0.04 because this negative is this one basically. So b is just without the minus sign.
Okay.
Okay?
Yes.
If you say b is negative 0.04, then it would have become positive here.
Okay, sir. Got it.
Alright. For example, if the examiner would have used a positive sign here instead with the b, then you would have written that b is minus 0.04. Okay?
Okay.
Alright. Now you can rearrange your answer as per the examiner's arrangement. So that's going to be 2 minus 0.04 times x plus 10 whole squared. Got it?
Yes, sir. Got it.
Great. Okay. Now, we've done quite a lot today about quadratics. Okay, now the next thing is functions. We're not getting into details of the functions, but we're just saying we can quadratics, the functions in form of quadratics, okay? The functions of quadratics.
Okay.
Now, for example, you have y equals to, let's just say x squared minus 2x plus 2. Instead of y, if the examiner gives you f of x equals x squared minus 2x plus 2, okay? And if the examiner is asking you to find the roots of this function, then you have to set the function to 0. Like you need to say that f of x equals to 0. If f of x equals to 0, then x squared minus 2x plus 2 will be equals to 0. This will take you back to the quadratic equation standard form, and then you will solve it accordingly, and it will give you the roots of the given quadratic function. Okay?
Yes, sir.
So there's nothing new in that. So it's just about dealing with that accordingly. So I'm gonna wait a minute. Here is a question, exam question. Uh, do you have the book?
Yes, I do.
Right, open page number 27. Do you see question number 8?
Yes.
All right, the function f is defined as Question number 8, page number 27. All right, the function f is defined as f of x equals 3 to the power 2x minus 28 times 3 to the power x plus 27, where x belongs to real number, so you don't have to worry about that. Don't get confused. Now, in the first part, examiner is saying that write f of x in the form 3 to the power x minus a times 3 to the power x minus b. And if you look carefully, this, whatever this is, 3 power x, it's, this is double of that, isn't it?
Yes.
If I take square of this, I will have 3 to the power 2x.
Yes.
So that rule which I told you the other day, any equation, if the variable, one of the variable is half of the other one, it can be translated into quadratic. So what I'm going to do is I'm going to assume that let y equals 3 to the power x, then y squared would be equal to 3 to the power 2x. Okay? So this will make
Yes.
it easier for us. So the same function f of x can be written as y squared minus 28y plus 27. Now what is happening here is based simple factorization. Is okay?
Yes.
So all I have to do is factorize it by using middle term breaking method. So the product should give me plus 27y squared, and the sum should give me negative 28y. All right, so the product should give me 27. So, all right, 27 times 1, okay? So
Yes.
I'll both numbers with a minus sign because the sum is negative, okay?
Yes.
So f of x would be equals to y squared minus 27y minus y plus 27. I'll take y as common, so y minus 27, negative 1 is common, and y minus 27. That is y minus 27 times y minus 1. That's f of x. So I'm going to go back to the actual variables. So this implies that as y equals to 3 to the power x, and this implies that f of x would be equal, oh, okay, so I can't use f of x here. Actually, just leave it like that. So f of x would be equals to 3 to the power x minus 27 and 3 to the power x minus 1. Got it?
Yes.
So this was a 2 marks question. You get 2 marks for it. Next is part B. Examiner is asking you to find the roots. So I told you that in order to find the roots, you need to set the function to 0. So basically, 3 to the power x minus 27 times 3 to the power x minus 1 equals to 0. So that's for the part B. So I've set the function to 0. Okay? Now,
Yes.
apply the zero product property. Applying the zero product property. So that's going to give us 3x minus 27 equals 0, or 3 to the power x minus 1 equals 0. So that would be 3x equals 27. All right, now that's an exponential equation. So in order to solve this x, I need to make the bases same. So 27 can be written as 3 cubed, isn't it?
Yes.
And for the left-hand side, 1 can be written as 3 to the power 0.
Yes.
So from here, x equals 3, or x equals 0. Okay,
Yes, sir.
was it difficult?
No, it's actually easier
All right,
than I thought it was.
yeah, great. Now, if you look question 7, question 7, in question number 7, if you look at E part, so x has a power of 1, the function k, and then it has a power of 1 by 2 in the middle term. So it's clearly a quadratic because one of the power is half of the other one, isn't it?
Yes.
And if you look at part F, the first x has a power of 2 by 3, and the other one is 1 by 3. It's clearly half of the other one. So it can be translated into a proper quadratic. Okay?
Yes, sir.
So question number 7, all of these questions, you have to do it. All these questions are examples of coded quadratics. If you see question number 6 is an example of completing square method. What does it say? Write the function f of x, pure constant to be defined, hence or otherwise explain why f of x for positive for all values of x and find the minimum value of f of x. All right. We will be doing this later.
Okay,
The
sir.
function f and x given by this. Find 3 values of x for which the function f equals to function g. So you need to equate both of these. So it's going to be 2x cubed plus 3x equals 17x squared. Let me just quickly do it. 2x cubed plus 30x equals 17x squared. So 2x cubed minus 17x squared plus 30x equals 0. So it's a 3-termed equation, which is not quadratic. It's non-quadratic. And one of the power is not the half of the other one. So I will be able to translate into quadratic. So what I'm going to do is I'll take common. So I'll take x as common. I'll be left with 2x squared minus 17x plus 30. Now I have got quadratic inside, isn't it?
Yes.
And then you'll solve it accordingly now. All right, next is question 4 is same type, exactly same type. All right, that's it for today. So we'll have a lesson tomorrow as well, okay?
Okay, sir.
Tomorrow, same time?
Uh, can we have it in
Okay.
like the morning? Okay, no, yeah, same time is fine.
I'll be in school, I'm sorry.
Yeah, it's okay, sir. The same time is fine.
All right, because tomorrow we'll be talking about the same chapter, but we'll be doing graphs, okay?
Okay, sir.
So any question?